Good afternoon. Welcome, everybody. Welcome to this session. First of all, I would like to present myself. My name is Angels Castelnau. I'm working at Batrec Industry as commercial manager, and I'm very honored to share this session with Elena Cano, that is head of the Service of Contaminated Soils of the Government of Aragon. In this session, we will be listening to different projects or presentations of different scenarios of management of HCH waste in different countries and from different points of view, both technically and also, let's say, politically.
Well, I'm going to talk about the LINDANET project. It is a European project where we have participated several European regions. We will see it now. The LINDANET project has been the first network of regions working together to progress on the solution for the HCH management. This is a project of the Interreg Europe program, and it had two goals. First, to create this network. The network is a way to collaborate, to learn from each other, but it has also another objective, to improve the public policies related to HCH through the interchange of experiences among regions. Improve the public policies means that every partner that was participating in this project needed to be a public entity. So public bodies that were capable to change policies, that were participating in public policies. The 6 partners that we participated and that are part of this European network are, well, the government of Aragon as the coordinating partner, Xunta de Galicia also from Spain, the region of Saxony-Anhalt from Germany, the Rural Development Agency of South Bohemia of the Czech Republic, the Central Mining Institute from Poland representing the Silesia region, and also the Zooprophylactic and Experimental Institute of Lazio and Toscana representing the Lazio region. All these regions have problems of HCH pollution and are public entities trying to improve the management of this pollution. Which are the problems in a very summarized? In the case of Aragon, you have already seen it probably in many presentations. We have a factory and we have 2 landfills with 60,000 tons of HCH in each one of them. In the case of the Xunta de Galicia, they also had a factory producing lindane. They have a safety landfill with 140,000 cubic meters of polluted soil. They have a problem of scattered pollution because this lindane or this technical HCH was produced in the past, and it was used also for filling in constructions. In the case of Saxony-Anhalt, they also had a factory, and they have 3 landfills where they dumped this HCH waste, and they have a problem in the basin of one of the Mulde River because they had discharge of HCH into the river up to the year 82. In the case of the South Bohemia, it is a region of with a tradition of agriculture, so they have a problem with the lindane itself, with the use of agriculture. In Silesia, they also had a factory. They have detected 100,000 tons of HCH, and they have also the similar amount around the factory. They had a problem before starting this project about the responsibilities, who had to take the responsibility for remediating the site. Now they have progress after this project with this issue. And in the case of Lazio region, they also had a factory. They have a landfill. They have confined 60,000 cubic meters of soils, but they still have to detect more soils so that they don't have confined. And they have a problem because they also have a river, the river banks are polluted, and they had to restrict agriculture in this area. Well, these are the main features of the project. It was a 1.35 million euros budget, 85% funded by the European Union through ERDF funds. The project started the 1st of August of 2019, and it has just finished the 31st of January of this year. And which was the structure of the project? We had two phases. One phase for the interregional learning. In this first phase of 5 semesters duration, we interchanged experiences on how we manage this HCH pollution in each one of the regions. The idea was to know examples of managing and to learn from each other, to detect good practices, and to see if these examples, we could take them and we could apply them in our own region. During this phase, the first phase, we also designed in each one of the regions an action plan that we had to implement afterwards in a second phase that was 1 year duration. We divided the semesters for the interchange of experiences in different topics. The first one had to do with governance, regulation, and public policies on HCH. The second one on technical aspects, technical projects related to HCH, technical projects that have been developed in each one of the regions. The third semester, we discussed about social and health aspects on this pollution. And then in the fourth and fifth semesters of the first phase, we started to design our action plans, and we made a lot of workshops. And then afterwards, in phase 2, we started with this implementation. Well, these are some photos of the meetings that we had. We have the COVID pandemic in the middle, so we only had 2 presential partner meetings at the beginning and 1 at the end. This was a pity, but even though all partners were so committed that communication was very fluent, and the project has been really interesting and really useful for everybody. These are some examples of the exercises that we did in the workshops. We did brainstorming sessions. We did some scorecards to analyze the situation in each region. We did SWOT analysis also in each region. And detecting these strengths, these weaknesses, these opportunities, these threats, we started to plan this action plan that we put it into practice afterwards. But the interregional learning didn't stop at the partner of the project. Each partner also had a stakeholder group with the groups of interest of each one of the regions, such as other authorities involved in the problem, with competencies on the problem, such as social groups, such as ecologist groups, and so on. And after each partner meeting, the partners share their experiences also with the stakeholder groups to get their feedback and to take into account this feedback in order to improve the action plans that were prepared. These are some examples of the stakeholder meetings of different regions. And let's see some results of the project. During the first phase, during the interchange of experiences, we detected 15 good practices. Many of them had to do with transparent issues, governance issues, such as, for example, the committees that we had in Aragon were taken as a good example to be applied in other regions, the website, for example. So taking these actions of transparency, of good governance was a very good example for all partners. We also selected some technical projects as good practices. And we also had some good practices of monitoring, such as some biomonitoring experiences that the Italian partners had, and well, some other monitoring good practices of Aragon region. Every one of the regions, we selected at least one good practice from each one of the regions. And let's see the main result of this project. Each one of the regions elaborated the action plan. So you can see, I don't know if this is working, maybe not, but well, you can see some yellow points, some blue points, and some magenta points. Depending on if the action has to do with governance and transparency, this is the yellow color. In blue, the more technical actions, and in magenta, the monitoring actions. So you will see that many of the partners have implemented governance and transparency actions, all of them, but one. Also some technical actions have been taken, and also some monitoring. For example, in the case of Aragon, we made a redesign of the HCH website. We have a specific website. We realized that it was not reaching the public properly, so we redesigned it, we made it more intuitive, and so on. We also made, as a request from the ecologist, a study of the forest mass at the Bailén landfill in order to minimize the forest risk. We also implemented an APP for the health and safety of the workers that are working there in these sites, in order to improve the system, to make it more automatic. And we also create, and we are still finishing it, a library, a physical library on technical articles of HCH, so that everyone that is working there can check it if they need it, so that we can optimize the human resources that are working in technical projects there. In the case of Galicia, we have some representatives here. They made a lot of governance new actions, such as they created an institutional committee. They also are creating a website. It's not finished yet, but they are creating a website for transparency. They are working also in a protocol for warning in case of detection of HCH waste. And they also improved the monitoring of the security cell of tornadoes in order to make it systematic monitoring. Regarding the South Bohemian region, they have organized a methodology for increasing the capacity of the professional staff that is working on POPs in general, to increase their knowledge. And they also have created a methodology, a document, so that everyone that is incorporated in these issues can be easily updated on these issues. Saxony and Halt have also have created some committees, scientific committees, social committees, and institutional committees as bodies for informing and for coordinating all the issue of HCH management. And they have also prepared a technical report on the Linden heritage. In case there is a renewal of staff, this will be always there. And they have also started some steps for an integral Malde floodplain management with a more detailed characterization of the Malde river basin. In the case of Silesia, where they had this problem of responsibilities, they had created a task force group, in order to unblock this problem that they had on the allocation of responsibilities. And in June or in July 2022, they achieved this goal to unblock the issue and to allocate the responsibility for remediation. And in the case of the Italian partners, they are doing a technical study to see whether any crop could be cultivated there, and they made a study on the accumulation of HCH in some specific crops, in order to, in the future, maybe allow some kind of agricultural activity that is currently forbidden. So, well, yes, this is the overall project results in numbers. We made one webinar for informing about the project. We made an article that can be seen in the project website, one booklet, several joint studies that are available for partners. I'm not going to enter into details, but everything is in the website. We made these 6 action plans, 6 newsletters, 6 international thematic workshops among partners, some study visits, 15 good practices, and a lot of policy learning events. Many or some of you might have assisted to them. So this is all. You have there the link for the LINDANET project, and in general this has been a project where I think that it has been very successful for many partners. I think that we have progress mainly in the governance issues and the commitment of every region, and it is really a pity that it has finished, because this collaboration has been nice and has been very fruitful also. And well, we will see if we can continue it in the future. So thank you very much.
Thank you very much, Elena. I think your presentation has been very interesting. It really shows how the collaboration between regions needs to be the path to follow. As John Vijgen said yesterday, the regions need to be together and work together, and that's a good proof. It's the path. Joao Paulo Torres is a full professor at the University of Rio de Janeiro, and welcome. He will present HCH in Brazil, Socializing Chemical Risks and Others. Thank you very much.
Thank you so much. It's a pleasure and an honor to be here in such a beautiful place. So, the problem in Brazil is based on the overall situation of the weak economy and our past. I will make a kind of counterpart on the situation here in Spain, mostly because I read this paper some days ago, and I took this to us, the similarity between dictatorships in South America and also in Spain. It's important to see that HCH is the principal product of several brand names, and one of those more interesting to me is the 666. This is a kind of advertisement here in Spain, more or less around 1950. In Brazil, we had production of lindane, and the site I'm studying belongs to the government. The Ministry of Health and the Ministry of Education run a factory in the 50s. Some people say that it's still fabricated somewhere. In Brazil, only one state, the state of Paraná, make a program in the 90s and the 2000s to get back the product. Remark that in Brazil, if you say HCH, nobody will know about it, but if you say BHC, then you can find more information in the popular newspapers. This was the campaign to get rid of these stocks when Stockholm Convention started working in my country. So, but in the 50s, you can find several advertisements of BHC saying that it's a miracle substance. So look to the cows. You are beautiful because you used HCH. This is another formulation when you have a strip of paper and then you put on fire and get rid of mosquitoes in your house. The gamma-hexane, number 22. So you can see that one application, you get rid of all insects for your house in 1 month. So you use it in coffee, you use it all around the country in different brand names and also factories that most of them belong to North America in that time, and then Brazil decided to make his own factory. So BHC against bugs that also transmit diseases. Interesting is to see that Brazil is in 1767, we see 300 years ago, made a kind of overall geographical mapping of the Rio de Janeiro area. So why Brazil is such a complicated country? In the past, it was much more organized in my point of view. Such organization means that they started this factory in the river that runs through a wetland. This wetlands is still today, when heavy rains, people are flooded. So the area, the overall area of where this factory produced lindane for only 5 years, still remains the pollution there. And it's called Cidade dos Meninos, meaning the city of boys, where poor families put the students just beside that factory. So you have a school and you have the pesticide factory. But this is the only measurement they did, a kind of sign saying danger, danger, a fence. Looks like that nobody cared, and in fact, nobody cared about it. This was the place, this is the place today. So Rio de Janeiro state have some horrible situations of pollution, especially nearby Rio de Janeiro. The official reports say that we have at least 20% of the contaminated areas you can find lindane. Then they started removing the people who live there. This is 25 years ago. This indemnization never come. So when the Stockholm Convention arrived, we started, at least we are going to see such move. We made reports, but the reports, if you go back a little bit, it's a kind of tricky to understand why this situation is still present in my country. Not only because we have factories, but also soap operas that describe more or less the situation in the past. This was a soap opera based on a very important opera, and the text is full of cynicism. This means that the society understands that rubbish can be put on the land and the land will be priceless. It's more or less the same thing that we realize here in Spain or in other countries. But the propaganda, for instance, if you can have cigarettes made on chocolate, but also, this is a real nice book on last year, How to Sell a Poison. So you will start seeing that the same product in 1920, in 1950, has lindane and DDT together. This is, now we know that this causes cancer and make hormonal disruption. But when you interview people, they say, my father manufactured BHC. I was raised in that mist. We use it as a miracle substance. But that's it, the miracle arriving in Ohio, contamination, pollution, last week. I think I just, if you need more information about that site or about other sites, John Vijgen and me, we have a friendship more than 20 years, so I will be very glad if you need more information on that. Thank you very much, but don't enter that area.
Thank you very much, Joao Paulo Torres. I think it's been very interesting the way you have gone through all this graphic material to understand how HCH has been handled and presented in Brazil. Is very interesting for us to have also the point of view of how this happens in other parts of the world. Thank you very much. We would like to welcome now Zoe Caos, PhD at Cretus, course research in environmental technologies from the University of Santiago de Compostela.
Good afternoon, everyone. This is Zoe Caos, and I will talk to you about our work, the spatial distribution of HCH in Porriño, which is in the northwest of Spain. As some background information, and as you know, the production of lindane has left us the greatest legacy of a persistent pollutant, persistent organic pollutant. As Elena said previously, in Spain, one of the municipalities impacted by this issue is Porriño. There was a lindane factory between 1948 and 1954. As it was usual, those wastes were dumped in landfills in open air. And then by the mid-90s, with the new regulations made by the Galician government, different waste sites were identified. We will call them PV1, PV3, and PV4. And we will call the previous factories EMP1 and 2. PV1 was identified as the main dumping site. In the 2000s, there was a containment of the soil, and then in PV3, we could see that the levels were standard, so therefore only the closure of wells was published. Then we can see PV4. This was a study in order to have a research on bioremediation alternatives between the year 2000 and 2010. Up until then, people thought that this was under control, but then in 2018, as Elena previously said, this waste was used in some construction sites, and then in 2018, some wastes were identified. And now we can ask ourselves, which is the current extent of HCH contamination in Porriño? And secondly, which were the main transfer routes? In order to reply to these questions, what we did was to carry out a sampling of topsoil and quercus rubber leaves. At the end of December 2021, we used those leaves because monitoring is an effective alternative to conventional systems in large-scale sampling, because this is a low-cost and reliable alternative. Also, in previous studies, as this one that you can see on the screen, it was proved that plants can have the capacity to accumulate HCH, and this happens on the leaves because this is through volatilization and deposition. So we used Carvalho because this is quite common in this region. For this sampling, we designed different designs, and we can see that there is a cross in the highest concentration point, which would be CV1, and we also added some points between the former factories and the previous dumping sites and landfills. And as you can see on the image on the left, the morphology is based on the basin. So Porriño is on a valley, which comes from the north to the south, and it has a central fracture. In order to guarantee to have a good representation of this space, we decided to carry out a transversal and longitudinal transect and to cover areas with different uses of the land and with different heights as well. In the end, what we did was to sample 46 soil samples and leaves. In two cases, we put this into the lab on the very same day of the sampling. The leaves were kept at 5 degrees and the topsoil was dried. Then it was stored in environment temperature. In the case of soil, there was pressurized extraction, and in the case of leaves, this was through ultrasound. In both cases, we analyzed the extracts with a gas machine and also with the mass spectrometer. Both methods were validated when it comes to accuracy, and we also did some recovery tests with percentages approved by EPA, so between 70 and 90% for all the isomers. Here we can see the results that we obtained from the sampling. Those results indicate that both the quantity and distribution of HCH isomers were different in the soil and leaves sampling. But in any case, this indicates that there is a transfer of HCH via soil, atmosphere, and leaf, and that the type of isomer will be the one having an influence in volatilization and later accumulation in the plant.
I would like to add that, as you can see, this kind of tree can accumulate HCH, and we could say it could be used as a biomonitor. In most of the points where we sample, we didn't find HCH, or it was just traces. As you can see on the graph down below, the distribution of the frequencies of HCH total concentration is a normal value with a median of 0.028 grams per kilo. That's below the detection level, with a median of 0.02 milligrams per kilo. In the leaves, the values of concentrations were more varied. But we could see the distribution was normal, in this case with that median 0.071 milligrams per kilo up until 2.8 milligrams per kilo. And we saw here that the predominant isomers were gamma and alpha. In both cases, what we could see, and it's a coincidence, the points that have a higher concentration of HCH are located in the old landfill, which is the PV4. So we decided to go more into detail in this area, and we did some parallel measurements using as a reference points where samples had already been taken in the past. So here we saw an heterogeneous distribution of the HCH in this plot, and we can, according to the concentration, we can see three kinds of distribution: in the east, low; in the north is high; and an intermediate concentration of HCH in the rest of the plots. The place where we can find a high concentration is the B2, and in 6 of the 11 areas that we analyzed, we found that the concentration of the HCH was higher than it should. And here, most of the isomers we found were alpha and beta. This could be explained by the fact that this was a discharge point. And also the beta isomer is the most persistent and has a great stability. It is not very biodegradable. As I said before, the PV4 was used to research bioremediation strategies. So we had data from before, so we could be able to compare data from 2001 from 2022. We could see, of course, there were several differences. As you can see in the picture, there has been several changes. And in 2001, already some raw lindane waste were detected. We didn't find them in 2022. And we could see that the predominant isomers were still alpha and beta. And also the point of the higher concentration of HCH was the same one as 2001. We also observed that the concentrations had decreased dramatically, and that means there's a higher heterogeneity in the northeast area. In the soil samples, we saw a diminution of a 10 times diminution of the HCH concentration. And in the case of the leaf, it's 20 times less. There's 20 times less concentration. This decrease could be explained by the historical decrease of HCH in the soil, but it could also be due to the different capacities of accumulation of plants, because we did use leaves from different trees than in 2001. So what did we learn? We can learn that the PV4 is still a contaminated area, and in the rest of areas that we sampled, we didn't find any official contamination. And the Percu rubber, we would like to present the Percu rubber as a monitoring tool to detect HCH and its changes. And that would be my presentation. Thank you so much for your attention.
Thank you very much, Zoe. I think it's very interesting for all the audience to see also the involvement of the University of Santiago de Compostela in the research regarding the linden legacy in one of the regions in Spain that has suffered of this contamination, which is Porriño in Galicia. I would like now to welcome Roberto Sainz. Roberto is head of the Department of Soil Contamination of Diego Hermanos. I'm particularly happy to be introducing Roberto because I've been glad to be working with Diego, collaborating with some projects regarding mercury. And so for me, it's a double pleasure to welcome you. Roberto will be speaking about the characterization and management of linden-containing waste at an abandoned linden production facility in Sabiñánigo, and that is the site that is the proposed visit for Friday. Thank you, Roberto.
Okay, thanks everyone. Thanks for the introduction. First of all, I'm going to take just a quick minute. I know it's after lunch, but I would like to see if you're active enough to notice that I'm not the guy that is right there. That's also not my name. That hands-on technician that is behind that full mask is my colleague, David Revuelto. He should be here due to personal matters. It's impossible for him to attend, but he's the production manager in our transfer waste plan here in Zaragoza. And he's the person that actually has been involved in pretty much all the projects regarding HGH and dealing with the problem in the area of Encinosa. So thank you, David, for this hot situation that is for me now to present his work, but I hope to be up to the task. So real quick, I come from Diego. We are a company located here in Zaragoza. It's a company that was based some 50 years ago, and since the origin, we've been very linked to the industry sector. In fact, we are now, our services pretty much cover the full scale of a life cycle of an industry process. We support with chemicals to the industry. We deal with, we have an environmental division that actually manage all industrial wastes. We have a consultancy department that I belong to. We also have engineering and water treatment unit, and we are now developing our business into agricultural. So we basically belong to industry. That's our leitmotif. And this experience has led us to, we are actually pretty proud that we've been a partner with the government of the regional government here in Aragon to collaborate for more of a decade in different projects in the Encinosa area. As probably you already know, Encinosa is the legacy that we actually have here in Aragon. I don't know, it's in the Pyrenees and it's a beautiful place, and it's a pity that we have this problem right there. So regarding wastes, we've been involved in different projects, waste inventory, different conditioning programs, action plans for dismantling the old landfill in Bailín. And actually, we are the company that is involved with the waste management of different wastes that are produced for activities such as investigation and remediation programs that are taking at the moment different sites in the Encinosa macro site. So I want to talk about a real case, a practical case. This presentation is about Encinosa. For those of you that are not very aware with the site, Encinosa is an old factory. It's no longer active, and I don't have the time to get into detail, but I want to show you just some important topics that are critical to understand the works that are carried out. Basically, the last period of Encinosa's activities, they had to deal with a problem. They didn't have the landfills active anymore, so they have to think about a solution for the process wastes, and they came to a very practical solution. So they start to store our wastes inside the factory. So the landfills were not available anymore. Okay, so let's accumulate all the wastes within the facility until finally the factory was abandoned, but the wastes remained within the factory boundaries. There was a critical and a major environmental issue, so the regional government in Aragon started an action plan. We started to collaborate in that plan 2010, starting with a waste inventory. So we made a catalog of all wastes present within the boundaries of the factory. 2017, first conditioning works. Some of the wastes were disposed in very poor conditions, so we needed the first task was to provide elements for proper containment until actions were taken. And then afterwards, 2021 was the latest works, final conditioning program, where basically we had to again deal with conditioning works to meet with the standards for transportation and final treatment of these wastes. The final treatment is supposed to be incineration, and it's something that it has to be done. So if we think about an action plan to deal with waste conditioning and preparation for final treatment, Probably we all share, it will be pretty straightforward to think that, okay, you need an action plan. First goal, you don't want to make things worse. So the environmental footprint of your actions has to be positive. Okay, that's pretty straightforward. And second goal is that workers need to take some actions on site, and protection of those workers is paramount. So, okay, those goals are pretty basic, and what's the challenge? Basically, the challenge is to be able to put that in practice. Is those goals, you need to design a program that is dynamic, that is effective, that actually works. So that's pretty much what it's all about. So, workplace preparation. Okay, we were working inside of an abandoned factory. That's a risk itself. So the place didn't suit much of the standard conditions that we needed for a work like this. But we had a few things in mind that were very important. First, we needed to prevent particle and dust dispersion. So we were about to open those wastes again, put them somewhere. We needed to do conditioning works, and to do so, we thought of okay, so we needed indoor space to do that. We selected one of the buildings that remain outside, but to actually ensure that we could make a truly containment work, we accomplished some conditioning works in the building. So we built a soft wall plastic bubble inside the building to create a containment area that all the works were taking place inside. We also modified the access of the building, and we built a two-door transfer and isolation zone. So to access and to have any exchange within the inside of the building and outdoors, those two doors provided an isolation area. And we, after we had these two conditions, we also inspected the original pavement of the base of the building, and we repaved all the base, all the ground, and we built a leachate drainage system to collect any leachate that was collected to a pond that is within the facilities. So all these works were previous to take any action, and yes, workplace preparation. Waste conditioning, the work itself, so that's the basic approach. So we had different containers stored within the site. Because of the conditions for final treatment in an incineration plant, pH control was compulsory. We had first to segregate the wastes according to pH conditions below or pH 4 was the threshold. And then afterwards we did this segregation. We extracted one by one each of those containers inside the bubble to put on the ground all the wastes and operate with them. And we designed a specific hopper for loading and transfer the original big bags into 60 liters drum containers that it was the condition imposed for the incineration plant to properly transport the wastes for final treatment. So all these works were carried out inside the bubble, and final results is that we needed 1,900 drums to accomplish the conditioning works. We set 208 pallets of these wastes properly managed and properly conditioned for final treatment. We selected an outdoor storage area for new drums, not contaminated, and then filling process was controlled because we had weight restrictions depending on pH of the waste. We also had the sealing process and marking of each pallet according to the conditions for final transportation. And now all the wastes are now in a storage area indoors, waiting for final treatment and for final waste labeling that is pending. Last topic and aspect of the working plan, but is the last, but is probably the paramount aspect of the work, is that health and safety issues. We needed first a safe protocol. We needed to design a work protocol that actually works, and I insist that that's the challenge. It's pretty easy to think about solutions, but to take it into action is the difficult task. The key of the success is that to have a specifically trained personnel that actually is involved with this type of works, that actually is used to wear this type of equipment, and that actually is it has a safe culture, a safety culture that and is involved with all the preparation tasks that involves a work like this. We had some restrictions in terms of exposure duration. 6 hours a day was the maximum time for workers to remain in the site. Disposable personal protective equipment, if it was possible, like Tyvek suits and gloves to restrict contamination transfer. Respiratory protection was another key issue. Within the project, we use a high pressure breathing air system connected to the bubble, and also portable respiratory equipment when needed. We had inside the bubble an extraction system to accomplish a negative pressure area with activated carbon filters to properly treat all the gases and air current coming from the working zone. And we also transported a portable decontamination unit to properly change and to establish a black and white area for workers, and to define the boundaries between the area that had a major risk for the works and the clean area for workers. So that's pretty much the works that we accomplished. It was a success, I have to say. Things were properly done. Workers are safe, still are, and still are willing to accomplish more works like this. So thank you very much, and thanks for your attention.
Thank you very much, Roberto. It's also an asset to see how valuable is the contribution of not only governments and university, but also as well from the industry. We have now finished a block of 4 oral presentations. Before going to the next block, we would like to make some summary of what we've seen. In these 4 oral presentations, we have gone through two practical cases in Spain, one in Galicia, one in our beautiful Aragon. And we've also had an overview of how the problem was addressed in Brazil. And Elena has showed the result of the common action and network between affected regions. So clearly we need networking, we need research, and we need remediation. Let's proceed to the second block. Thank you.
Well, now in the second block, we are going to see some examples. One example of the remediation of the Kuhlmann factory. We will see also the efforts that Slovakia is doing for the identification of the polluted sites with pesticides polluted sites. And we will finally see the actions made by Macedonia for the cleaning of the contaminated sites. So now our first speaker will be Martin Forter. He is an online speaker.
My name is Martin Forter, and I will talk to you about the example of the HCH factory UGINE-KUHLMANN in Gzyl, France, in Alsace. I'm talking about the remediation done by Novartis 2012 to 2019, and about the question if the French inventory fully covers the LINDANE waste of this factory. Just for documentation, 90 1933, there was a US patent document date indicated the insectal activity of HCH. The document remains unnoticed. A rediscover of the insectal activities by French and English researchers was in 1941, 1942, and in, why doesn't it work anymore? And in 1947, UGINE-KUHLMANN starts its production in Junac, France. Why there is so much waste? Until about 1955, HCH was applied to fields in Europe and in the United States as a whole. The result, hexa potatoes and stinky vegetables. Because only the gamma isomer of HCH, the lindane, is insecticidal, the industry separates it from the other isomers. This means 50 to 20% gamma isomer, that's the sales product, that's the insecticide lindane, and 80 to 85% other isomers, that's the lindane waste, the HCH waste. The worldwide lindane production was about 600,000 tons. The worldwide quantity of lindane waste is about 4.8 to 7.2 million tons. Lindane waste is so a worldwide problem. Also at UGINE-KUHLMANN in Junac, there had been mountains of lindane waste, as you can see here. The factory was directly at the border of the River Rhine and at the border to Switzerland and Germany. This is the site during the total remediation in 2018, and this is the site today after finishing the work. The Novartis hexachlorocyclohexane remediation wasn't very noiseless and especially not dustless. The wind was bringing the dust, the HCH dust, over the city of Basel in Switzerland, means over the Rhine to the city of Basel in Switzerland. So because of that, Novartis was stopping the remediation work in September 2013. The original planned remediation cost had been around 100 million euros. The effective remediation costs had been around 300 million euros. Novartis brought out a book about this remediation with the title Difficult but Right. There, Novartis is talking how they prepared the remediation. In 2011, they drilled about 76 boreholes. However, in order to determine the extent of the contamination, a further 300 boreholes have been necessary by the end of the work. The lessons learned from the project, how it's written in this book, the grid of the test drillings at 20-meter intervals provide insufficient in our project. And Novartis also write, among the most important findings is that remediation must be approached with a profound analysis of the initial situation. A lot of information was not available in a requested level of detail. The fundamental self-criticism that Novartis exercise in this book is gratifying and extraordinary. But what happened to Novartis is what my partners and I have warning about for years. Surprises are expensive. Surprises can be prevented with elaborated historical investigation and very intense analysis. This saves money later on during the remediation work. Despite difficulties at the beginning, Novartis wanted to dig out the Lindane waste at Gynaec. This is to the credit of the pharmaceutical company and its employees. In this book, also John Vijgen, co-organizer of the HCH meeting here in Zaragoza, was also writing an article. He writes about the first remediation company which was working in Gynaec and which was contaminated the city of Basel with Lindane waste by wind. The contractor who dug up the Lindane waste in the first phase of the remediation did not make a particularly organized impression, he is writing. This is very friendly formulation because Sita Remediation, the company who was doing the work, was engaged the city of Basel and the environment with its improper work. In this book, Novartis is also looking at other sites with chemical waste and how the handling was doing with this industrial waste over the time. One of these sites is the Remisloch, the chemical waste dump in Neuville, France, not far away from the factory site of UGINE-KUHLMANN. And there, Sita Remediation, the same company, was also doing the cleanup. But the municipality of Allschwil in Switzerland recently detected, among other things, the highly cancerogenic benzidine far above known limits, and there shows directly below the two company alleged cleanup of the dump into 11 on behalf of BASF, CBSC, Novartis, and Syngenta. So it's the question, really, if Sita Remediation was working there better. In this book, there were also named other cleanups like Bonfol in the region of Jura in Switzerland, where had been excavated 360,000 tons by companies as BASF, Novartis, Syngenta, and Roche. Or the case of Kestel in Grenzach-Wielen, Germany, also in the corner, also close to the river Rhine, there had been excavated 360,000 tons by Roche. Or the case of Kölliken in Switzerland also, where had been excavated 660,005 tons. And at least the case at UGINE-KUHLMANN at Novartis, there had been excavated 788,000 tons. So it's the hugest excavation that had been done in Central Europe until now. These examples of total remediation are showing getting rid of chemical waste and the pollution soil underneath for once and for all is feasible, if you want. The complete excavation of the chemical waste and the polluted soil underneath is the only right way to definitively solve the problem of waste sites and not to pass it on future generations. This applies to all hazardous waste sites, but especially to the former chemical waste site of the Swiss chemical pharmaceutical industries, CBSC, today BASF, Lonza, Novartis, and Syngenta in Alsace, in southern Germany, and as well as in Switzerland. And for the remaining Lindane waste from UGINE-KUHLMANN, Gynaec, mostly in France, but also in smaller part in Switzerland, as we will see. As you know, Europe, the European unity, is doing inventory of the HCH waste in Europe. The French Lindane waste inventory was compiled by TAR, CDM Smith, and Sarga. Does this inventory covers all sites where Lindane waste of UGINE-KUHLMANN is located? It doesn't. We know about 12 sites with pure Lindane waste dump. Only 8 of them are to find in this inventory, 4 are not to find, they are not listed. Then we know about sites with Lindane waste from the UGINE-KUHLMANN site, means ground and other things, material from the factory demolition, they are all not listed in the French side. And we know about gravel, which is contaminated with Lindane waste and which was brought to different communities where you can find it in roadbeds and also in dirt roads. That's in Switzerland and in France. Not one of these sites with contaminated Lindane waste from UGINE-KUHLMANN is to find in the inventory. So there are 11 sites with Lindane waste or Lindane contaminated material from the UGINE-KUHLMANN Hünag site, which is not listed in the French inventory of Lindane waste. This is astonishing because we already listed these sites at the 13th HCH Pesticide Forum in Zaragoza in 2015. It was co-organized by Sarga, then as it is again this year. Sarga was also collaborated on the French Lindane waste inventory for 2020. So it's really astonishing that you can't find these contaminated sites in this inventory. It is important to complete the French Lindane waste inventory because it's the first step towards the definitive elimination of these chemical waste. The complete excavation of the chemical waste and the contaminated soil underneath will definitively solve the problem, even with the remaining waste from UGINE-KUHLMANN at other sites, for example, in Winsenheim or in France. There, the work of excavation will begin.
Martin, please, if you can
shortly.
begin in finishing.
Yes, I will.
You can conclude.
And last until 2029. It is also good that local residents are joining together to ensure that the lessons learned by the Novartis in excavation the Lindane waste in Hünag is implemented at Winsenheim. Thank you very much for your attention.
Thank you very much, Martin. It is really interesting, this example of self-criticism that you have elaborated in that practical book. Is very useful for other HCH cases, of course. It's also good to know that it is feasible to end with this pollution. Of course, there's this, in many cases, this problem of the huge cost that it involved. But in any case, it has been very interesting, and it has been also a good example on how complex this remediation is. Thank you very much for your presentation. Alexander Mikowski and Zuzana Andonova, assessors of the Ministry of Environment and Physical Planning of Macedonia.
My name is Alexander Mickovski. I'm coming from the Republic of Macedonia, from the Ministry of Environment and Physical Planning, POPS unit. And also on behalf of my colleague Zuzana Andonova, I'm going to present the results of a project related to the remediation of an HCH contaminated site at Ohis facility. The project was donation by Jeff in amount of $3.1 million, national co-financing $12.5 million, implementing agency UNIDO, and executing agency POPS unit. Based on some previous investigations, previous studies, 16 industrial hotspots have been identified in the Republic of Macedonia, and The same were ranked based on environmental parameters, and OHI's site was ranked as the #1 priority to be solved. Some quick information about the plant history. OHI's factory produced Lindane from 1964 until 1977, when the production was abandoned due to ecological reasons and market conditions. And about 2,800 tons of Lindane has been produced, and about 25,000 up to 30,000 tons of waste inactive HCH isomers were generated and dumped onto two pits, so-called bigger dump and smaller dump. The bigger dump is only the pit was excavated. HCH waste was dumped on bare ground without any isolation, covered with soil. And the smaller dump, there were 5 concrete basins where the HCH waste was deposited and also covered with the soil. The OHI's factory is very close, maybe 200, 300 meters far from the residential area. During the preparation of the project document, we revealed that there are many deficiencies, many gaps in the management of contaminated sites. So there was no infrastructure for management of contaminated sites, meaning that there was no legislation, no institutional technical capacities, especially analytical capacities for determination of the POPs, including the HCH. Also, there were no finances for cleanup activities. Therefore, with the project, we wanted to overcome these deficiencies with a long-term objective to have the OHI site free from HCH waste in order to be able to use the site for industrial purposes. These are the project components. I'm going to say some word about every of the components. The first component was related to the preparation of the legal acts, technical guidelines, etc. So legal acts regulating each phase of the contaminated site management, including identification, remediation, monitoring provisions have been prepared and adopted. The technical guidelines and tools for sustainable contaminated site management, safe contaminated site management have been prepared, and all these technical tools encompasses the entire phases of the contaminated site management, including preliminary site assessment, detailed site assessment, remediation management, monitoring and aftercare, and then standard operating procedures for majority of the activities previously mentioned. The company Tao was engaged for the preparation of these technical tools. These are the examples of the technical tools here. And also training was organized for the relevant stakeholders, environmental officers from the ministries, environmental inspectors, environmental consulting agencies, on every aspects previously defined in the technical tools. These are some pictures of the on-site training. Laboratory personnel from the 2 laboratories have been trained on eco-biomonitoring in Resetox in Brno, Czech Republic. So they were trained on sampling techniques on different media, different matrices, analytical techniques, then on basics of risk assessment analysis, and on management of the data. The next component was related to the detailed site characterization in order to define the exact scope of the extent of the contamination. So boreholes were drilled on the bigger dump, smaller dump, on the perimeter of the dump area. Here you can see the pictures, profiling of the core, sampling of the different waste fractions, and after the analysis, the different waste fractions were identified, quantified, and with the corresponding HCH concentrations for each waste. And at the end, the estimations were that in the smaller dump, there are 1,600 tons of HCH waste, while there are around 5,000 tons of HCH contaminated soil and concrete. And the same for the bigger dump. The bigger dump, the quantities of the HCH waste were around 40,000 tons, and HCH contaminated soil above 10,000 tons, with the concentrations of overlying soil of HCH. 3D maps of the bigger dump, 3D maps with the HCH concentration representing 3D map of 3D model of the smaller dump, cross sections, identifying the layers of the different waste fractions, and the 3D model of the smaller dump indicating the HCH concentration. Also, superficial soil samples have been taken at the different distances from the OHIS factory up to 17 kilometers in order to define the background levels of HCH. So none of the superficial soil samples exceed the Dutch intervention values, although in the majority of them some minor concentrations of HCH have been identified. Samples from vegetables have been taken in 3 locations, and in 3 samples only the alpha isomer, HCH isomer, was above the maximum residual level. All other parameters were below the detection limits. Also, air was subjected for analysis. 2 sampling points were identified at OHIS itself and in the residential area, and the samples were taken prior, during, and after the site investigation after the borehole drillings. And in the OHIS, the sampling point located near the dump site, the concentrations of alpha isomers exceeded the maximum acceptable toxic concentrations, while for the sampling point located in the residential area, the concentration were below the detection limit. The groundwater was also subjected for testing. 15 monitoring wells previously installed at OHIS factory were tested, and 3 domestic wells as well. So from the groundwater testing within the OHIS premises, in all 15 monitoring wells, the values of HCH and mercury exceeded the intervention value, while in the domestic wells, the results were between the target and intervention values. Based on the results obtained during the detailed site investigation, the company MGRISA prepared a risk assessment analysis. And in this analysis, the sources of contamination were identified: the exposure pathways, the receptors, the contaminant migration, the risk characterization, identifying the unacceptable risk for certain receptors, and designing proper risk management options in order to reduce the risks. So this is suggested area for the groundwater, installation of groundwater monitoring plan, and the area where the usage of groundwater should be restricted. And this is the potentially affected area by the inhalation of vapor and particles. The third component was mainly related to the awareness raising activities. So this component was very important in order to avoid or to amortize any negative reactions of the public towards future, let's say, remediation process that might, let's say, result in stop of the process. Therefore, the public was introduced to the project and the benefits that the global, let's say, environmental aspects of the decontamination of the remediation itself. Therefore, the general survey about the current level of knowledge among the residents was conducted. Awareness raising workshops were conducted. Awareness raising materials prepared, disseminated. Then cleanup activities were regularly promoted in the media. And also panel discussions were organized with the contractor for the remediation activities, Polyeco, where the NGOs, local residents, media were presented, discussing about the progress of the remediation itself, the problems identified, and the control measures taken in order to overcome these problems, and video material was presented. These are some pictures, some slides, pictures of the questionnaires, report on survey of awareness levels, and some articles in the media and promotional material. Cost-benefit analysis was prepared as well, with the main objective to quantify the costs and the social public health benefits from the intervention, demonstrating demonstrating that the project will be beneficial to the society and therefore justifying the cleanup activities. And the fourth component was related to the cleanup activity itself. So the output 4.8 will be elaborated later on by Polieco, by the contractor. So at the beginning, the TOR was prepared, defining prescribing the scope of services, the safety requirements to be implemented in order to avoid odor, vapor, dust emissions, etc. So I would like to thanks to John Vijgen assisting for preparation of the TOR and also to Tao. Upon the evaluation of the offers, the company Polieco was selected for the remediation, to perform the remediation activities. The site remediation plan has been prepared, reviewed by the Ministry of Environment, also in cooperation with Tao, and upon finalization of the same, the Ministry of Environment issued the approval of the site remediation plan. Main, let's say, very important aspect of all of these preparatory activities was to design a proper monitoring program. So the monitoring program was designed by, let's say, defining the media that is to be tested regularly, the frequency of testing, the parameter that needs to be tested, and the sampling points. And also the decision tree in case of exceedance of the target, of the limit values. Also within the project, we procure some laboratory equipment, gas chromatographic analyzers to 2 laboratories in order to enable them to be, in order to enhance their capacities to be able to test POPs, in our case, HCH, in different environmental media, in water, soil, air, and also in human blood. And contract, okay, of course, have been signed with the laboratories. These are the 4 sampling points installed in the working area. So more of this will be presented by Polieco. These are the results of the monitoring, and the Ministry of Environment was responsible for monitoring of the air in the residential area around or in the proximity of Ohis dump yards. So the frequency was weekly samplings at 2 locations, and the results shows that the levels measured during the remediation activities are much below the limit values previously defined. Also, Polieco is obliged the contractor is obliged to collect the wastewater, the rainwater from the environmental enclosure, and to measure the same. And okay, more of this will be presented by Polieco, I guess. And also, great attention was placed to the health condition of the workers. So regular medical checkups of the worker were performed, general conditions, and the presence of HCH in the worker's blood. So no HCH was detected. It was performed 3 months after the remediation work started. And the last slide is related to the establishing of financial mechanism to continue with the remediation activities. So the government of the Republic of Macedonia formed a multi-partner environmental fund with the main aim to mobilize mobilize fund to generate funds in order to continue the cleanup activities, in order to complete the cleanup of the entire site, not only on the smaller dump, but also on the bigger dump, and then later on cleanup of the mercury contaminated site, because in this factor also there was a chloralkali plant with massive of mercury contamination. Okay, that will be all. Thank you for your attention.
Thank you very much, Alexander. Thank you for giving us the details of this characterization, investigation, monitoring, and all the decision tree and all the details regarding the actions for cleaning the site. Now I invite to George Simons from the International Project Manager for Polyeco.
Good afternoon, everyone. My name is George Simons. I'm International Project Manager for Polyeco. Following the previous presentation, I was the responsible person for executing of the project. So therefore, we'll be discussing about the same project, which is actually the remediation of Ohis plant in Skopje, North Macedonia. So far, the project has been divided into 3 lots. We will be discussing mostly about the first one, employer of which was UNIDO. Just a few words about Polyeco. We are a Greek-based global hazardous waste management company. We have been active in the hazardous waste sector for the past 20 years, and we have executed projects in many countries globally, like Bangladesh recently, Ethiopia, Djibouti, North Macedonia, and so on. Regarding our project, as mentioned before, we are discussing about Ohis, which was a former organochlorine pesticides production facility. We're discussing about the small dump or delta dump, and under Lot 1 contract, 481 tons of HCH waste along with 127 tons of HCH contaminated soil was dealt. The project is ongoing, and we have just finished Lot 2, and we are about to commence Lot 3, and more or less additional 1,000 tons are being dealt under Lot 2 and Lot 3, respectively. Just a few words about the steps and stages that we moved. First of all, after the award of the project, we prepared all the necessary documentation as the remediation plan, health and safety plan, and so on, to be submitted to local ministry for approval. We procured later on the equipment for the field operations. I have to mention that the procurement was during the corona situation, therefore there were huge delays for the procurement and the delivery of the equipment. After the arrangements for the issue of the transboundary permits for exportation of waste out of North Macedonia, we commenced the field operations, which actually commenced by site setup and the preparation for the repacking. The major thing that we had to do actually was install the environmental enclosure. I will get into details later. Later on, we started the excavation works, which include the packing of HCH waste into drums and the soil into the bulk containers, safeguarding of waste, exportation, final disposal, and finally, submission of file reports and certificates to UNIDO. One of the steps mentioned before, it was the remediation plan that was submitted, that included actually all aspects of the project. More or less, it was submitted in September 2020, and eventually it was approved in April 2021. In terms of equipment, I think the most important equipment that the site currently has actually, it's the negative pressure units. We ordered 2 items of this. Each one has a capacity of 90,000 cubic meters of air per hour, and it's operating with 3 types of filters. It's German-made, and it was imported from Germany to North Macedonia. Another critical equipment of the whole operation is our filling station. The pointer unfortunately doesn't work to tell you what everything does. More or less, the waste is being excavated and is being fed up in the back, and finally it ends up in the feeder where drums are filled, and later on they are getting out of the enclosure for safeguarding. It was manufactured by Polyeco and it was imported from Greece. In terms of filling of the soil into the specialized containers, we constructed actually this rail system for the specialized containers to go inside and outside from the tent. It was custom designed and manufactured in North Macedonia. The environmental enclosure, as mentioned before, it's the most critical part of the whole project. In order to construct it, we had to make foundation all around the delta dump. You can see here some images of the operations. In order to make sure that no cross-contamination takes place, we had to put geomembrane and plastic sheets all over the excavated part, as you can see in this image in the corner, and the excavated soil is being currently stored in temporary depots on site. This is the environmental enclosure. I don't want to tire you with many technical details. More or less, it's 50 to 50 meters and 19 meters height. It's a huge thing, but it's enough actually to make sure that no dispersion of dust takes place. The overall structure weighs more or less about 80 tons. It's resistant to 9 Richter scale Mercalli rate earthquake, as mentioned in the TOR. This environmental enclosure after its completion. You can see here some internal view of the negative pressure units and the internal view in general of the tent, of the enclosure. In terms of site setup, this is the entrance of the site. After the installation of the environmental enclosure, we installed lighting system, office container, and sanitary facilities for working personnel and for polyeco personnel. Health and safety signs, the decontamination corridor with the decontamination trailer, as you can see. Before the commencement of works, we had to make some training to all involved parties and stakeholders. You can see here myself actually performing some health and safety about the correct usage of PPEs. This is part of the equipment that was, or the personal protective equipment that was used throughout the project. This is the zoning of the site. The small dump or delta dump, it's the red zone, obviously, which is enclosed by the tent. Outside is the yellow zone where mostly it's used for temporary storage of safeguarded material, and the grey zone where the office containers are. There are 3 zones. The red zone is the most dangerous one, let's say, because of the fact that lindane actually is free present, therefore the exposure to lindane is higher. So in this case, we have to wear the highest standards of PPEs, which in our case is the helmet, gloves, chemical-resistant glove, and the full face mask. The yellow zone, in comparison to the red one, the risk of exposure is less. Therefore, instead of a full face mask, you can wear a half face mask or a dust face mask. And respectively, in the green zone, given the fact that there is no presence of lindane waste, the level of PPEs is this one. You can completely, let's say, just wear a dust mask. Some words about the excavation after the whole site setup when we eventually started the project. We started by excavating the contaminated soil above the first basin until we reached the lindane. We had to use a portable XRF in order to identify the level of concentration at all stages, just to make sure that there's a complete discrimination between HCH waste and contaminated soil. The soil that was removed was temporarily stored in piles inside the enclosure over the basin. Of course, we applied plastic sheets to avoid cross-contamination. Later on, we did some sampling on those piles as per LAGA standards. Those samples were delivered to local laboratory in Skopje, and also they were shipped to Czech Republic and Netherlands for analysis. And based on the results, it was defined whether this material is either soil or HCH waste. And the soil, as we'll see in next slides, was eventually packed in specialized BK2 containers. Just a few pictures of what we did actually. The first picture is the removal of top layer. And this is the XRF screening of what we are digging, and based on the results, we have a first image of what we are excavating. This a sampling of a soil pallet we excavated. And this is packing of the soil into the specialized containers. As you can see, plastic sheet is used in order when it's offloaded in Germany to be easier and to make sure that we don't contaminate the container itself. After the completion of packing. In the same way, we're operating for the HCH until after removal of the contaminated soil. Eventually, we had a clear front of the HCH waste. Then, at that point, we started feeding the filling station that I showed you earlier. This is when we finally reached the bottom of the first basin. This is the feeding, the transferring of the HCH waste into the filling station, where it's being fed by the conveyor for packing. And this is a revolving platform for pallets that are operating in order to fill up the drums. After the filling of the drums are being cleaned and taken out of the enclosure, were being weighted and temporarily stored, safeguarded until their final exportation. This is the labeling as per ADR and IMDG regulation. This is what we have how we have to label the waste. This is a picture of the preparatory activities before the exportation, a final cleaning of the drums, check that the labeling is on, and these drums are being loaded in containers for later to be transported to the Thessaloniki port and later on to France for incineration. These are some pictures of the loading of the containers, where the containers are grounded on site, loaded, later on moved by a crane onto platform trucks, and moving out of the site. In the same exact manner, we are operating with the contaminated soil that is being packed in the BK2 containers. It's being fed, it's being loaded onto platform trucks, and it's traveling by road to Germany. One major aspect, as Alexander, 1 minute, okay, I will do it very fast. As so before, I didn't manage my time correctly. Anyway, one very important factor is that OHIS is neighboring with other workshops and houses, so it's a very important thing to monitor there. There's a constant monitoring of the air in OHIS. Besides the LINDANE, we are also measuring dust and other gases. We are also monitoring the water. We are collecting rainwater and any washings that are being filtered through this activated carbon filter, and later on this is being moved and sampled. And the most important factor of all actually is the well-being of our workers, including ourselves actually. We made blood analysis and medical checkups during the works. And this is the blood analysis results for LINDANE. None was detected in any of the involved personnel. So this is actually, a way to prove that everything was successful. I won't mention this at all. It's regarding the, okay. So regarding the final disposal, as mentioned before, HCH waste was destined to France for incineration, while the soil has been transferred to Germany for thermal treatment. These are the tables of the final disposal, the certificates as submitted to the client. And just a few conclusions very quickly. We faced some major issues in reference to the licensing and transportation, because at some point the route of the maritime route changed and different countries were added. So therefore we had to issue some new licenses, which requires a lot of time. Also, there was some, let's say, a rejection of the Dutch authority regarding notification that we had made. Therefore, we had to find an alternative disposal solution, which also delayed us a bit, but we managed to find an alternative solution for the soil. And that's it, actually. At this point, I want to thank all the stakeholders of the project for their cooperation and support. And this proved to be a successful project, even though in the beginning it started with the worst omens. Thank you so much.
Thank you, Yorgos. A very practical presentation, very nice with the photos. Thank you very much. Yeah, we could see all the processes, and it's really interesting.
Few words before we start with the presenting of the video, which was developed during the public awareness campaign. We believe that it was very well prepared video, but I would like first of all to thank to all the collaborators that were responsible and of course supporting us as a POPS unit under the Ministry of Environment to make it realistic, this project, because at the very beginning when we have started with motivating the investors and all the funds, available funds, to get the funding for this project, starting from Global Environment Facility, then UNIDO as an implementing agency, the Ministry of Environment and all the ministers that showed understanding as a decision makers to make this project successful. I believe that until the end of the cleanup activities, we will see only success and no obstacles, although they are expected, of course. Thank you all, and I hope you will enjoy the video. Thank you.
За мене охис е темпирана бомба која што еве сега пробуваме да ја деактивираме.
За мене е линдан и жива. Двата збора за охис.
Ohis site is a contaminated site, which is located actually within the city boundaries.
Долгогодишен еколошки проблем, на кој навистина посветивме огромно внимание, труд и посветеност.
Некогаш индустријски гигант со десетина илјади вработени. Денес, самосеќавање на едно време и систем кога сјај беше синоним за средствата за миење садови. Билјана беше врвен бренд за рачно, а гонг за машинско перење. Кога вештачката кожа и скај наоѓаја разни примени во индустријата за мебели и облека. Синтетичките влакна имаја широка употреба во цела лепеза на производи во поранешната федерација, а инсектицидите и пестицидите произведени во охис го осигуруваа производството на земјоделски производи низ недогледот на задругарските полиња. Денес, сјајот на некогашниот охис е згаснат, но неговото влијание врз животната средина никогаш не било поистакнато. Перзистентните органски загадувачи, ПОПС, го загрозуваат животот и здравјето на луѓето кои живеат околу некогашната огромна фабрика. Меѓу нив линданот, односно хексахлороциклохексанот, чие што производство престанало во 1977 година, речиси половина век го загадува воздухот и шири непријатна реа, ја контаминира околната почва, а преку подземните води се влева во блискиот Вардар и оттаму продолжува со контаминација долж неговото течение. Две депони, една голема и една мала, 45 години чекаат да бидат соодветно исчистени, а заканата која тие ја представуваат за животната средина, конечно да стане минато. Зад проектот за отстранување на линданот и ремедиација на теренот околу големата и малата депонија во охис, стојат долгогодишните напори на Канцеларијата за перзистентни органски загадувачи при Министерството за животна средина и просторно планирање.
Прво бев храбар да ја инициирам проблематиката преку Обединетите нации и уште при ратификацијата на Стокхолмската конвенција, кога го правивме националниот имплементационен план, ние го воведовме линданот како потенцијален кандидат за решавање на проблемите.
Во моментот кога линданот влезе на листата на хемикали од Стокхолмската конвенција, веднаш имавме право на барање на средства од меѓународните фондови.
Проектниот документ беше подготвен од Канцеларијата за ПОПС во соработка со меѓународна консултантска компанија, каде што се дефинира активностите кои што треба да се извршат во проектот. Една од активностите е и чистењето на локацијата. УНИДО ја публикуваше таа проектна задача, тој Terms of Reference, се воспостави тим за евалуација на понудите од страна на компетентни луѓе и се избра најсоодветниот изведувач на чистењето.
Polieco is the successful bidder of the tender that was issued by the United Nations for the execution of this project. There are two main waste streams in the context of the project. One is contaminated soil with lindane, and one is actual lindane. Therefore, what we are doing is we are excavating the upper layer of soil in layers. Then we are classifying based on analysis that we're performing on site and on laboratories. And based on the classification, we are packing this for further treatment. As soon as we reach the lindane, it is excavated and packed through a conveyor filling station into UN-approved drums, waiting for their loading in containers, further exportation, and final disposal. The whole project has been designed and executed with the highest environmental and health and safety standards. The actual site is divided in 3 different zones: the red, the yellow, and the green. They are related to the risk present at each zone. Each zone is related to specific personal protective equipment that should be used and must be used during personnel's presence at this zone.
Во текот на работењето, значи не беа идентификувани некои отстапувања од пропишаните соодветни мерки за заштита на животната средина и безбедност и здравје при работа.
In terms of packing lindane waste, specialized UN-approved 220-liter drums are used. Contaminated soil is packed into specialized BK2 bulk containers. They are loaded onto platform trucks on their way to Thessaloniki port for further exportation.
Во он одобрените сини буриња беше складирано вкупно 450 тони линдан, а жолтите контейнери со себе понесоа 126 тони контаминирана почва. Во меѓувреме се бара чари за големата депонија на линдан.
Well, before the questions and answers session or the discussion session, I would like to say some conclusions of this, all these presentations that we have seen. First, we have seen very good examples of management and monitoring of sites polluted by HCH. Very nice projects of managing this pollution. But we can see that there is still a lot to do in many places. It is important, very important, the public awareness on the problem. It is also important, the public information to communicate the problem, to communicate all the actions that are being undertaken to the general public. And it is essential, the commitment of either the direct responsibles of the pollution, if existing, or either the subsidiary responsibles that are usually the public authorities that are in charge of this. A part of this commitment, and with reference to the LINDANET network, it is very important, we have seen that it's very important also the coordination among public authorities to progress on the issue and to learn from each other. And well, I think that this is all. We can go to the questions and answers. I don't know if anybody has any question.
Guido van der Colet from TAU. I have a question, no, not a question, a comment on the presentation of Martin Forter on the Huningue site in France. At the end of his presentation, he mentioned that there is a number of HCH sites that were not identified during the inventory of the EU. I think it's a very good example that these inventories are never finished. During the whole process, we have asked multiple times for the audience to come forward. We did our due diligence. We contacted Claude Muller of Novartis, who's the remediation manager. So we did do a thorough job on that, and we asked multiple times for people to come forward. It's clear that, you know, sites come up and people know things, and it's impossible to know everybody, even at a small conference like this. So taking that in mind, I think we should inform the Commission that these documents should be living documents, and we should be able to continue to add sites while we encounter new ones as they come. That was my comment. Thank you.
So first of all, I would like to clarify something, and is that all the time we're talking about HCH as an environmental problem, but I wanted to add that it is also a safety and public health problem in the project LINDANET. It was said that the forest mass was being studied or was going to be studied. We performed some tests on trees on several dams, and most of them have very high indices in their wood. And I think it is concerning that there's a lack of protocol to protect ourselves against this, because we can be harmed. And of course, the first that they're going to be affected by this is staff that work in the forest, and in the event of a fire, people who are going to work in those fires to extinguish the fires are going to be affected by that. So if those protocols do not exist yet, they should be created. On the other hand, I would like to know if the effects on wildlife are being studied, because of course we do consume the products of hunting. So at the end of the day, if prey have these high concentrations of HCH or lindane, they're going to end up in us through the food chain. I think this is a safety and public health problem. So I think one of the main actions that we have performed in Aragon as a response to the petitions of the ecologist sectors, I think Mariano was present in one of the stakeholders meetings of LINDANET. We carried out a study of the forest mass, where and there was some recommendations. Some parts of the forest close to Berlin were perimeter, they were enclosed, and we are working to boost the rest of the recommendations, and we have recent results of these weeks. We have analyzed the forest mass and to determine which part of the woods next to the old dam should be eliminated to protect people. And every day we're seeing that the population is less when it comes to wildfire. The population affected in the woods is less and less every year, but the final results of this analysis will be available soon. And in case that, of course, anyone asks for that information, we're ready to make it available. When it comes to the studying of the wildlife, we also perform some analyses, and the results are published in our web. We launched a new web last week, and you can find the results of that report there. Actually, that information is public now. You don't need to ask for it.
Okay, yeah, I have a question to the team from Macedonia. You said that there are two spots contaminated, and you selected the smaller one for decontamination, and if I understand correctly on the video, the bigger one is still there and there is no solution. Why you did not apply for the both for funding?
Thank you for the question, Sasha. So it would be ideal if we could manage to mobilize funds to clean up all the contamination, but having in mind the large quantities in the bigger dump, around 40,000 tons of pure HCH, 10,000 tons of contaminated soil, or altogether around 80 to 100 million US dollars. So it was not possible to obtain that much of assistance. Therefore, we were focused on remediation of the smaller dump. Also, in the meantime, we approached to Jeff whether we will be, let's say, eligible to ask for another tranche for the bigger dump, and they said that they can give us about 10 million US dollars, but only upon successful finalization of this remediation. Yes.
Hello, my name is Dirk-Jan Hogendoorn from the Orion Company. I actually have no opinions, but 2 or 3 questions. The first question is about the public awareness raising for the Macedonian project. How did the population respond? Were they concerned? Were they relieved? Were they happy to be monitored? Did you raise more questions than you could give them answers? How did it go? How did the people feel about it?
Thank you for the question. So, as I mentioned, the public awareness campaign was critical for the process, for the project. So we were very transparent at the beginning. Also, during the drafting of the project document, there were some surveys, some studies testing the public, let's say, knowledge about the problem. So at the beginning, the public was not that aware about the problem. Somebody of closest residents know about it because they were mainly affected by usage of the groundwater for irrigation and some other things. So we explained them that there is a problem with the project. We are going to solve the problem. In the meantime, during the realization of the project, there might be some, let's say, problems. Some odor might appear, but we are going to take every measure to avoid any odor and dust formation. And that's why they were very, let's say, positive. They have positive reactions, and moreover, during the remediation process itself, there were regular panel discussions involving the media, NGOs, the residents were present there. We discussed about the progress of the remediation, the problems that we faced, the control measures taken to overcome the problems. So everything was very good up to now. Yeah. No, nobody asked for compensation. Okay, in the past, when the problem started to grow up, when the groundwater was restricted to be used for irrigation purposes, there were no requirements for a residential to receive some compensation due to avoiding, let's say, the possibility to grow the vegetables, to sell the vegetables on the market. There was no such issue.
Does that also have to do with that there was a former regime that caused the problems, and now there's a different kind of government? That people have in the Netherlands, they would be claiming like crazy.
I don't know how to answer this question. So the problem was created in the past. Now there is a new maybe system, some, let's say, democratic, let's say, governance. But okay, nobody, I don't know how to answer this, yes. The problems were created in the past. Luckily now we are eligible to receive some funds. Also at that time, nobody, let's say, pay attention to the environmental damages. Now we are all aware and we are dealing with the problem. So from the residential public point of view, we did not face some problems.
So it gives them more rest than that it creates additional unrest, you would say.
Sorry, please repeat.
It gives them more peace of mind. They're more happy that it is taken care of now than that they are made aware of a problem they didn't know.
Yeah. You're right.
Yeah, I have a question for Polyeco regarding the export documents and all the tricks you have to do to make sure that when there's an itinerary change or a route change or maybe a different transport company appearing. Should we make an appendix to the Basel Convention to explain how you actually have to submit for a successful Basel notification?
It's a good question because I think that 10 years now, not a lot have changed in terms of exportation. And okay, the main scope of Basel Convention is to protect from illegal transport of waste. But what about when you want legally to give a solution to the problem? And if you see now the new regulation of European Union, and if you see what is happening with the projects around the world, exportation is becoming more and more and more difficult. We are facing even crazy requests by competent authorities. There are cases, for example, a competent authority may come and say, why the vessel comes from my port, you should go from another port, but this is not the contractor's control, it is the maritime transport company that defines the route. For your question specifically, there are cases where some authorities are flexible and maybe they will accept the addition of another port. There are cases that are not flexible. I believe together with other companies that are also expert in this field, yes, we shall make some comments to the Basel Convention. We usually do comments to the revision of EU regulation, but nothing is happening. A very easy comment, for example, is I don't believe that the transit countries where there is no transshipment, the container is not unloaded in the port, then they shouldn't be giving their consent. So there are a lot of things that can be highlighted, but I don't see it happening.
We're trying to get China to be on the program and get with the program, but they're very good at blocking a lot of stuff we experience, yeah. So basically there's governments that don't want to cooperate.
It's political. We see the practical part, but it's also a lot of policy behind. But for the case of this project, there was also a specific problem in the Netherlands. You are aware of it. The Dutch authorities rejected a lot of notification following the PFAS contamination identified in the country. So it was something that was a national issue, and nobody could change their opinion.
Yeah, they're kind of they're like English and like cream. The harder you whip them, the stiffer they get, I think. So that's definitely a thing, yes. And I think what you mentioned that you put a lot of alternative ports and routes in the notification.
This is what we do usually. You have the main route from the shipping line, maybe contains 7 countries, and the actual notification from our side contains 20 countries. And we expect that suddenly no additional country will appear and will destroy the project.
Yeah, because they change the itinerary every 6 months, and after 9 months you get the approval, and then the route has changed already again. Yeah. So we have to be kind of inclusive.
There are cases where they will change the route even without notifying anybody, and when the vessel is during its trip.
Yeah, stuff like that.
Thank you.
Okay, so should we put that as a kind of addendum, or maybe how to obtain a viable Basel notification?
Thank you very much.
Thank you.
I can add that we from BATREC or SARP Veolia, we have a great deal of experience about Basel Convention and movement of hazardous waste. And as you say, it's not a science, it's case by case. It depends on the country, on what the countries are interested or not, on what you're doing there. So that's a complicated issue, and it's part of our experience as you shared.
Have you given any thoughts about the possibilities of reuse of the site? I mean, what's the purpose? Because at the long term, I guess the site is pretty close to the urban area, and is the government going to keep the control, or is there any possibility of reuse or given, I don't know, residential use or any other?
Yeah, thank you for the question. So, based on, in accordance with the detailed urban planning, this site, this location is dedicated for industrial, for commercial purposes, not for residential. And besides this HCH dumps, there is also, as I mentioned previously, chloralkali plant with major, let's say, mercury pollution over there. So these two, let's say, sites are main contaminants, main contaminated, let's say, area. So the plan is to clean all the site in order the same to be able to be used for industrial purposes, not for residential, because for the residential purposes, the limit values that are going to be obtained during the remediation works are quite low, and we cannot go, let's say, that low.
Good afternoon. I would like to clarify something. And first of all, I would like to say thank you to the team. I think it's great to have an inventory that we all can check to have an idea of how Europe is being affected by LINDANE and HCNC. I hope this tool will be improved. When it comes to about the sites in the Basque Country, I wanted to confirm that we gave all the files and all the documentation. And I see all these sites are on this tool. And when it comes to the question about fires from the Basque Country, we are coordinated to the emergency services. We have all the information available, and we have self-protection plans. We do drills every year, and we hope it doesn't happen anything regarding forest fires, but we do have all the data about forest mass and soil and air and water. So we have everything. We have everything to act properly. That's what I wanted to say. Thank you. I wanted to say to Javier de Ecologistas Nación that we share his point of view. And it's true that sometimes we focus too much on the environmental aspect, but this is also a matter of public health, and we really appreciate his comments because we think they're really relevant.
Then we can close the session. Thank you, everybody, for your presence here. And you can go for the hall for a coffee. We can continue the talk there. Thank you very much. Thank you.